Hi everyone, welcome to another episode of the Cabinet Vision Guy. In this episode, we're going to continue our series on JavaScript, and we're going to start to look at the topic of converting a traditional UCS to a JavaScript UCS. Now, I figured the best way to do this would be to look at a practical example. So what I've got up here is 3 examples of a UCS. So the idea with this episode is we're going to take a look at the original UCS, a converted version, which is just a literal conversion using our internal convert function. And then we're going to take a look at another version of the same UCS, which has been optimized, or something I've attempted to optimize using JavaScript. So I'm going to start off by explaining what the UCS does. And I've got the traditional UCS enabled at the moment. I've got a single base assembly inside my job, and I've got a face frame construction. And essentially what the UCS does is it replaces the current face frame of the assembly with a single piece, and it adds routes for every door or open that we've got on the face. So I'm just going to run through and add some section in and then apply the UCS to show you what it does. Now what I'm going to do here is just make sure I've got a few different opening types. So I've got a drawer, and I'll just stretch this out so we can see it properly. There we go. I've got a drawer, a door, and I want a pair open as well. And I think I'm going to split this one, and I'll set this one to be a pair door. I'm not too bothered about the size, but what I want to make sure is that I've got a few different opening types, and I'll show you why in a second. So I'm just going to set this to open. Now if I just take a look at this in 3D for a second, you'll see that we've got, again, a few different opening types. So we've got a drawer, a door, a pair door, and then just an open. And if I take a look at the cabinet itself on the face, what we'll see belonging to the face itself is a few different opening types. These are really important because our UCS that we're going to look at in a second uses these opening types to essentially dim the route operations that make up the openings in the solid piece. So the next thing I'm going to do is I'm just going to hide everything and just make everything disappear. And what I'm going to do is just enable my solid frame UCS, and I'll set texture mode on so we can see this. And what we've got is a single panel that makes up the face of our assembly, and if we just take a look at it in the object tree, we've got a solid frame part, and then we've got a set of routes that represent each opening type that we've got in the face of the assembly. So let's take a look at the UCSs that are driving this. So the UCS itself is split down over 2 individual UCSs. We've got a single UCS that is applying to cabinets, and this is adding the parameter, which is set to be an attribute, which is allowing us to toggle on or off our solid frame. And then we've got another UCS, which is actually adding the solid frame and all the routes for us. So the first UCS, if I just head up to code, is really short and simple. It's just for each cab assembly, if solid frames equals null, then we want to set it to be false to start off with. We want to set the style to be an attribute, and then we want to add a description as well. And again, this just allows us to toggle on and off on assembly level. The next UCS is the bit that actually does the adding and dimming of our solid frames. So right up at the top of the UCS, we've got this set for each face assembly. So if we've got multiple faces within an assembly, it will also add a solid frame component as well. We then check if our parameter is true, again, just to enable us to enable or disable this UCS. And then the next thing that we do for each face, we dim a solid frame component. We set the visibility as true, obviously. For the sizes, we set that to be the overall face size. And we check one of the standard numbers. I think this is whether the frame's going to be the inside or outside, just to set the Z position. And then we come into the section where we're actually going to be dimming the operations to the solid frame part itself. And the way this works is up at the top here, we start a number of counters for every different opening type that we're going to find on a face. So that would be a door open, a drawer open, an open, and a pair open. I think there might be another one. What we do is essentially we start a loop, and we loop through each different opening type to find if this opening type exists. We do that with a while statement, so we say while this dot door open at, and then we've got our count number there, dot dx is over 0, so essentially checking if it exists. We then check the S type, and if that equals 1, we then dim our route operation to our solid frame component. So we set the owner of this operation to be the solid frame part. We then set the X and Y positions and obviously DX and DY sizing to be the open size. And then we set different properties for the operation, things like face work plane, rcut, and the tool ID as well. We repeat this for, as I said before, each different opening type. So there's a loop for every door open, there's a loop for every pair door, and then there's a loop for every drawer, and then every face open as well. And this is how we make sure that we capture all the different face opening types that we might have and make sure we've got operations to account for that. So there are several different loops within this UCS, and we're looking at about 175 lines. It's obviously not the most complex UCS, but it is a good example of how we can approach things a little bit differently using JavaScript. So the next UCS we're going to take a look at is the literal conversion of this. So I'm just going to disable this one and we'll take a look at this. So with this UCS, what I've done is I've selected my original UCS and I've hit convert to JavaScript, and these are the results. And what Cabinet Vision has done is it's created a literal conversion for us into the JavaScript syntax. So if we just take a look at that UCS, I'm not going to enable these ones, but I just want to take a look at the code so we sort of know what to expect when we convert in UCSs. So if we just take a look at the code here, you'll see this looks very similar to our previous UCS where we're adding a parameter down on cabinet level. We're setting that to be an attribute and then obviously setting a description and allowing us to toggle on and off the rest of our UCS. If we just take a look at the bulk of the code here as well, and just move throughout our UCS, you'll see again, this looks very similar to our previous UCS. It's just got our new syntax. So essentially what this is doing is the exact same thing. It's setting a parameter up here for managing the tool ID, and then we're checking our parameter that's been set on assembly level, and we're dimming our solid frame component, and then we're setting parameters now on cab level to manage a count internally, and then again we're working through the different while statements to build up the different route operations that are applied to our solid frame component. So essentially it's exactly the same UCS, just with the JavaScript syntax. And this is what you can expect if you convert a UCS from the traditional language to JavaScript. This is fantastic for taking a look at how the UCSs are converted. It's fantastic for creating example code and knowing what a literal conversion looks like. But what we can do is utilize the full power of JavaScript and look at the original problem in the first place and look at how we can solve that a little bit differently. So what we've got is a third UCS that I've optimized for JavaScript. Now there'll be people who look at this who think, oh, it can probably be done in half the amount of code. It probably can. This is done to the best of my ability at the moment. So what I'm going to do is just take a look at code and then take you through what I've put in here. So the first thing to note is we're actually just using one UCS to achieve the same thing. We can do that because we can affect parts that are outside of our for each loop. And we're doing that to apply the parameter to cabinet level to allow us to control the rest of the UCS right up at the top. We're also using a function that's contained within a library for managing the parameter as well. So again, it's just one line of code to get the results and store that as a JavaScript variable. So rather than querying this as a parameter, what we're doing is we're getting that here and we're just going to use that for testing throughout the rest of the UCS. So if enable solid frames is true, we then move through the rest of the logic in our UCS in this section here. And this is where things start to get very different to our previous UCS. So rather than having a while statement to loop through each possible face opening that we might have belonging to our face, what we do is we collect all of the face openings into a list, and we do that using the this.getChildren command. With this command, what we can do is we can pass a text variable to it. So I'm passing face open, door open, and drawer open as well to return all the objects that I need. And then what I can do is I can loop through that down here just with this for statement and add in my route operations. So just back up here, the next thing that I actually do in here is I then add the solid frame component itself. And again, what we're doing is we're adding the part using a function that's contained within a library. So in multiple UCSs that I've got, we're adding different components in. The same for the wine rack units we're going to be looking at in a few episodes time. So with this, we choose to use the CVG parts and we choose add part. We then pass the name, which is just a solid frame, and the height and the width as well. So if I just take a look at that function, and I'll skim right down, I think it's about halfway down. You'll see we've got add part. We can choose to pass more information if we want to add complexity, and again we use this throughout several different UCSs. So rather than writing the same code every single time, what I've done is just built a function and then stored that within a library, and again we can access that through any UCS. The next thing that we do is very similar to the previous UCS, we have to check the CV standard number for whether the frame fits on the inside or the outside of the assembly. And then what we do is we loop through each different opening and we check that for the opening type and then dim a operation to the solid frame component. Very similar to the previous UCS, apart from, again, we're only looping through the number of openings rather than looping through every different opening type. And again, what we're doing to add the operation, we've got a function that's stored within a library, and we pass in the operation name, the opening heights and widths, and the material thickness as well. And then we're just using the opening X and the opening Y, so the properties of the object that we get in here, to dim our operation. So just by going through the process of trying to optimize our code to better use the JavaScript functionality, we've actually started to create a toolkit for ourselves that we can use time and time again throughout several different UCSs in our system. And what I'm going to do with this is I'm just going to enable this UCS to show you in action. It's going to look very similar to all the previous UCSs. The only difference with this one is we've got a little bit of logic in there that we need to unhide the door components to see all the different operations. But you'll see that we get our solid frame part and all the operations to go with. Hopefully you found this episode useful. I will be sharing the examples we've looked at today on the Nexus community so you can see how some of the UCSs compare when we optimize them for JavaScript. Feel free to give us a like, share and subscribe. We're also on Facebook, that's facebook.com/thecabinetvisionguy, and Instagram too, that's instagram.com/thecabinetvisionguy. Cheers!